This is part 2 of building agents with LangChain and Langgraph. So in part 1 you have seen LangChain, and in this video we are going to talk about Langgraph. What we will cover in this session is we will first talk about what is graph, a very simple graph, what is node, what is edges, and then we will build a graph with a decision node. Plain vanilla decision node where there will be a function which will be making a decision. And the next we will build a graph with a smart node where LLM is in the middle and making decision for us. And then we will build a complete intelligent fully autonomous agent. Why it is called autonomous agent is because there's a node in which LLM is running, and this node is smart enough to call itself or call any of other nodes. It need not be in serial because LLM will decide which node to be called. So that's why this will be a fully autonomous agent and very smart one. And the last one is fully autonomous agent with a human in loop. And that's the only reason I'm creating this video, because there's a great tutorial on Langgraph on the Langgraph site itself. They have multiple videos, they explain it very well, and I recommend everybody must start learning about Langgraph there. But then why I'm creating this video? The reason is because in all those tutorials, they are showing all the examples with notebook. And for the human in loop, they will show that there's an interrupt in the graph, and the next cell of notebook you can execute it by typing, so which can resume your interrupt. But when you're trying to write the same code in, say, in Python, then you are stuck and you don't understand what's going on because you interrupted the code. Now how the code will start. So to understand all that, what has to happen is this part of the code where the graph is running has to be a separate code which is running as a Langgraph code, and then there has to be a client portion of the code which is interacting with graph. Now no one shows this example in YouTube. Everybody is just copying each other and showing this human in the loop with the notebook examples, and I got very confused that how to make this code work. And again, I have to go back to the Langgraph tutorial, understand how they deploy. So there was a lot of things, but fortunately you don't have to jump through all those hoops, because I have created this tutorial where very clearly and simply I will show you how you will create a part of the code which will run as a graph, and then will write a separate client code which will interact with the graph, and how the human in the loop things will happen, how the interrupt on and resume will work. So let's take a look at the code. So this is the first code we are looking, a very simple graph. We are just going to build some nodes and some edges, and how they will look. They will look like this. We'll have bunch of nodes and bunch of edges. And as I said again in my part 1, that don't worry about this code. This is all shared with you on the GitHub. And there's a README file which explains everything. Now let's look at the code. So when you are working with the Langgraph, of course, you have to bring all this utility functions. So first thing is we have to define a state. And this state is very simply a type dictionary, which is taking a list of base messages. And this state goes from one node to another node. This is the way the node talk to each other. And of course, there is something called annotated. By that, it means that you can add a function or another method or another metadata about this data. So read up about annotated if you don't know, but which means simply that this is my data. It's a list of messages, and I added another function called add messages. So when I am passing messages between one node to another node, this add message will be called by the Langgraph to add the messages. So we define a simple state. It's not necessarily need to be only messages. You can define anything more, string and any other data type into the state. And that data type will go from one node to another node. And then I'm defining bunch of these methods, add, divide, and multiply. Very simple. They are not doing anything basically. They are just printing that add is called and just appending a message to the state and then returning state. There's nothing much happening here. Same way, it's a multiply and divide. Let's skip that stream graph update for a minute. Here we are building the graph. Let me bring the graph here on the half of the screen. So as you can see, this is how the graph will look. We start with graph builder and state graph and pass the state which we have defined here, state, right? So that's how we started our graph builder. And then we add node. So how we add the nodes? We just give the node a name, any string, and a function which need to be called when this node is called. So that's how you define a node. Just the node name and any function for the node. And now the edges we have to define between these two nodes. The edges are defined as such. So you say add edge and then you write from and to. And from and to is nothing but the name of the node. Start and end are reserved words. So you start the graph by calling add, and then add is calling multiply, multiply calling divide. And this is how a very simple plain vanilla graph you have created. And now you are just compiling this. So you just compile this graph and then you can interact with this graph. Here I'm taking the user input, and that user input I'm passing to stream graph update. Now let's look at stream graph update. This method basically just passes the message which we got from the user graph.stream. So we pass this message, and stream means it will start streaming the event back to the caller from this graph. So as the graph will move and whatever things will happen, you will get events, and from the event we'll get the messages and we will print the message. Very simple, right? And as you can see, this graph is not doing much. It's just a simple graph of nodes, one after another they are calling. So as you can see, this is a very simple graph doing nothing, but this is giving you an idea how you can create node and edges, and slowly by the end you can create a very complex graph which is doing multiple meaningful things. So let's run it just to see how everything works. So now this graph is running. It's saying, welcome to the introduction to Langgraph, type quit to exit. And here's the user. Now let's say user input something, and I can just say maybe testing. Whatever I say doesn't mean much because I'm not acting on the message. But here you can see these messages. This is addition, multiplication, and division. This is came out of this print message. So what's happening, as you can see, I type testing, and this messages came out of the graph. Print assistant, and it's typing, assistant is typing the messages. So nothing happened. The node is called one after another, and they executed their messages. And because you are seeing this is addition, this has come out of this. I am appending this messages to the state. As you can see, state message append, this is division, this is multiplication, this is addition. So every node got called, every function got called, and we see this here because all these messages are printed. So now quit this. So this is a most simple, dumbest graph you have seen, which is doing nothing, but it is a graph. Now let's take a look at the next level, which is a Langgraph with a router. Now let's take a look of how this graph looks, router graph. So as you can see, there's a router node which is making some decision to route it to the next node. Now graph is taking a shape. I have multiple nodes and there's a router node which is routing the control to the next node depending on certain condition. So for that, what we have done, we have not changed anything, just we left state as is. Add, divide, multiply. These methods also I left as is. They are not doing much. They are just appending a message to the state. And then there's a router function we added. This router function is again, it kind of a dummy function, doing nothing much, but it's just checking the message, the last message on the state, and seeing if it's add, then it says go to add. If it's multiply, then the control goes to multiply, and same way for divide. Otherwise it will go to router back. And that's why you see this another line showing the router is going back. So this is the beauty of Langgraph, that looking at the code, it draws this graph, and which is very interesting and needed when you have big code, lot of nodes, a big graph. You need to see it visually, and we will see it later in the session how you can use the Langgraph tools to see these things. But today I'm just creating this Langgraph here. So now let's look at this. We created a router function which will route, and now let's create a router node. For that we will give create another function, because as you've seen, when we are creating the node, we have to give a function that for this node call which function. So the router node has a router node function, which is doing nothing but just printing thing, this is a router, and returning the state. And this router function, which is a separate function than the router node function, is called when we are doing add conditional edges. So we added the edges as before, simple from to, but now when we go to add conditional edges, we give the router node the name of the node, router node, and then the function which will decide where the control will go from this router node. And router node function, as you already seen, again it's a pretty dumb function which is just checking the message and returning back the name of the node, add, multiply, divide. Very simple. I'm going slow very deliberately, so once you will understand all the concept, it will be very easy for you to build a complex graph. And stream graph update, same way as we seen before. We stream and pass the message and then just print whatever the assistant says. Now let's run it. Now here I'm just typing add, maybe user typed add, and then we are seeing this is a router node visit because we went to the router node here, and then assistant replied add came out of this method, and then this is addition, then the add node is called because router function is just looking at message and routing. Now let's see if we say divide, you see it goes to divide node, right? This is division. So this is how you will route. Now you understood the creating the node, creating the edges, and router node. Now the next one will be a tools, how we will use the tools here. And in the tools, what we are going to do, we're going to change this router node with the LLM. Now our graph start becoming little smarter. And how that will look? The graph will look like this. Now in the middle you have a chatbot, which is nothing but an LLM, which is intelligent, which will understand your simple English statement, and it will route looking at your statement to different tools. And now let's see how this is built. So here, as you can see, I instantiated a OpenAI LLM, and this is the beauty of Langgraph. You can change this again tomorrow with anything else. It can be Anthropic, it can be Llama, or whatever model you want, DeepSeek or anything, you can just put it here. And LLM will be instantiated. State is as is, nothing changed much. Now we wrote a couple of things. One is, as now the chatbot is one of the node, so we have to create a chatbot node here. And then I need to have a chatbot function for the node, because as we've seen, whenever node is called, a function need to be called. So the chatbot function, actually it returns, it calls LLM with tools, invoke whatever the message there in the state, right? State is passed in every node. So whenever whatever the message has come, we are invoking LLM with tool. Now what is LLM with tool? Because we just did LLM here. So let's look at LLM with tool. But before we look at LLM with tool, what we have to understand now, these methods which were simple add, subtract, divide, we put a tool attribute on top of this function. Now these functions have become tools. And the way you've seen before, they were nodes and they were function, but now we put an attribute, so they have become tools. And what we do is we create a tools array and just put these functions, because tool is nothing but some function. And then we bind these tools to LLM. And that binding becomes LLM with tool. And that's what happens in the chatbot method. We call LLM with tools and pass the message. And we can see what happens there. And chatbot is smart and it understands English. It figures it out what tool I'm trying to call. And how does it all figure it out? Because you have all these commenting in these methods, which says it multiplies to number, it divides to number, and all that. And all this is with the attribute of tool. Langgraph took all this and does all its magic and converted these tool, and then it's become very simple. Now, a couple of more things we should see here. We are building the graph exactly as before. We are building different nodes. The difference here is we build a tool node now, this tool node here. In this tool node, we are passing the tools array in the tool node and then adding a node called tools, which is having a tool node, as you can see here, because this is array of tools, and which is here add, multiply, divide, and we can see it. We'll debug it later on, see how chatbot calls these things. And then we will put a conditional edge. Here's a conditional edge which says chatbot and a method called tools condition. And this tools condition is a special function by Langgraph. This you get out of Langgraph pre-built import tool nodes and tool condition. So this tool condition figures out which tool need to be called. Okay, so it simplifies very much. Now, if we will call this function and we'll see what's happening. So here we see these divide will really get x and y, and then it will divide and multiply and add, and start will, when the graph will start, we'll pass every message to the chatbot, and chatbot will decide which tool to call. And this tool node, it shows one node here, but there are 3 methods as we've seen here. Okay, now let's run it. Okay, it's running again. In message we say multiply 2 with 3. And you see the answer is 6. Actually, we wrote a plain vanilla English, but this LLM understood and called the proper tool to do this. So this is how you will build a graph with the LLM. Now, the thing which I wanted to show you again, they have another option called debug equal to true. And this will show all the messages going from one node to another. And as you see in my state is a list of messages, right? And this base messages, and there are system messages, human messages, and there's our AI message. And you will see all these messages flowing between one node to another node. And if you want to see, debug your situation, you want to see what messages are going, what is system writing, what is AI is writing. For that, you will just turn it on saying debug true. And now let's run this again. Okay, now here I am saying multiply 3 by 4, and you will see all these messages here. Very, very detailed messages are there. So it literally shows you what step it is, starting first task for step 1, and chatbot is receiving this message, multiply 3 by 4. This is a human message, and then you will see it is calling the finish step 1 with write to channel 1, and then this message pass, and this is an AI message. See this chatbot received this message, and then it responded with an AI message saying it is a tool call, and this is the ID of the message, and these are the arguments, and the name of the method is multiply. This is an AI message, and when the AI message goes to the next node and this Langgraph magic, it calls the proper tool. So this is a very helpful thing when you want to debug and you want to see how nodes are talking to each other and how the messages are going each other, from how messages are moving from one node to another node, and you can see all the detail here. So this is how you will build intelligent agents where you are using LLM to make a decision, and you have multiple tools and LLM decide which tools to call. As you can see, already this agent can be a very powerful agent. Now let's look another quick graph where I will have a search tool, right? That this time I was using very simple add multiplication now, but I want to put some search tool that asking LLM that please go to the web, search about things, and then come back. And to do that, what we will do is most of the things will remain same, but we'll create another new tool now. And this new tool is Tavily Search tool. And as I said, you will see in README, I have link on everything that you have to go get the keys. So all those things you can set up. So this is where we are setting up our search tool and saying just give me the top 2 searches. And now I am setting my tools array, binding it to LLM and LLM with tool. Now you can see it's all same. Chatbot is calling same way, LLM with tool. And here, as you can see, I created a tool node, and then I have all these different nodes, and then add conditional edges. Conditional edges, I pass chatbot because chatbot is the one where the LLM is called, and then tools condition. This is again a reserved function, but this is the method which helps conditional to make a determination which tool to call. And other edges we add here, and then compile and then just run it. So let's run it and see the response. Quit this thing and clear. So today Google has its earnings, so let's ask tell me about Google stock price and its earning report. Let's see. So now what's happening, because we added a tool which is a web search, so it went to the website, it's searching the web and figuring out this release PDF, because as I said, today Google released the results, and our question was, tell me about Google stock price and its earning report. So it's searching the web and getting the latest data, and here's the stock price. This is telling me a price in October 31st. So interestingly, even it's going to web, but it is getting a very, very stale data. But we don't have to worry about that. We want to focus. This is 23 earning, but I just wanted to show you here the working of the system so you can use the search. Now this search is not that smart as it's supposed to be, but that's besides the point. You can change the search with some other thing, like do a Google search or whatever else. And so you will get much more better and current data. The date today is February 4th of 25, but somehow it got us the data of 23. Anyway, because we are here to learn about Langgraph, not about this search results, but this is just to prove a point. So in this we will see the example of persistent layer. How a graph can remember its context, its previous conversation. So in this persistent layer example, we will see how you can add a persistent layer so the graph can remember about the previous communication, previous conversation. So I am showing you here example with the persisting the data in memory, but for sure this data you can persist in database also. But this is just to show you a high level idea how you will enable the graph to have a persistent layer. And to do that, before we do that, let me show you without the persistent layer, right? There's no persistent layer, so how the graph will behave. I'm running this code. Now I'm telling this graph, my name is Rafat. And it says, okay, Rafat, how I can assist you today? And then I'm asking, tell me my name. And it says, I'm sorry, but I cannot determine your name. Could you please tell me your name? So it completely forgot its previous communication. So it's not remembering anything. And now to make this graph have a persistent layer and remember your previous conversation, we have to just add this one line, checkpoint equal to memory. And what is memory? Which we have defined here. It's called memory saver. And where the memory saver is coming from? It's coming from one of the libraries here, memory saver. Langgraph, checkpoint, memory, all that. And you just added one line here. And that's it. Now let's see if this graph will have a memory or not. And this can be used because when we are having a human in the loop, human can show up after 5 hours or next day. So the graph can persist its state in database and then it can restart from a certain checkpoint. So that's where the checkpoint use will come. So now I'm testing and saying my name is Rafat. I'm telling the graph what's my name. Last time it couldn't remember, but now this time we'll ask, tell me what is my name. And it says your name is Rafat. So see, it remember the previous conversation. So what happened again, if you will see, look at this code, I'm going to check in. There's nothing very special about this code, but what's happening in the state, we keep passing the messages. And because of this checkpoint, even if the new instance is running, it remembers all the messages, and that's how it figured it out that you told me your name, now you are asking my name. Okay, now let's look at human in the loop. So here's the human in the loop. It's here now. Let me show you how the graph looks. Langgraph human in the loop. This will help you understand what's going on. So there are a couple of nodes, agent, action, and ask human. These are the 3 nodes are there. So as you know, we created a state as before, nothing changed here. Should continue, this is a method we wrote, which we will be calling in our conditional H in agent, should continue, right? After the agent, we'll call this method should continue, and where to go. What it is doing is, it is looking at the message, the last message, and if it's not a tool call, then it's going to end here. But if it's a tool call, then it checks the name. What is the name of the tool? And ask human. We'll define this ask human, see, as just another object, ask human. And what we are doing is using this to figure it out that there's a tool call, but then we call this ask human another method, which is here, right? This is ask human. So there are a couple of things. One is we define a class object called ask human and put it in tools. You see, we created a tool called search. This is the search method. This is another tool which does nothing basically. It doesn't even go to web. It's just a dummy search. It's just to show the concept that you can have multiple tools. So I created a tool, added search there, and tool node has the tools. And then I bind this tool to the model, and in the tool list, I pass this array of ask human. What's happening, why we are doing this? Because when we are binding this tool to the model, when the agent will be called, it will say, oh, you need a ask the human a question. So then using this method should continue, right? It will send us to ask human node. That's what trick is happening here. And this ask human node has this method which will do, it will, of course, it will get the tool ID, and then it will call an interrupt. This means the code will stop here, waiting for human input. And this was a very tricky thing, because all the examples everywhere on net you will see, they will show all this thing in a notebook. So then they'll go to the next section of the notebook and resume the call and everything will work. But now when I'm writing in Python, I don't know what to do. So anyway, we'll see that. Give us a minute. So this is interrupting and nothing happening much, we are just making a tool message and returning a message. Tools call ID and all that. So agent, action, ask human. This action node is calling the tool node, which is this tool node, which has just search tool. If it is called, it will call here. But then we add another node, kind of a dummy node, which says ask human, because this dummy node does nothing, but it just creates an interrupt. Okay, I hope it is clear to you. I'm sharing this code. You walk through this code. It's a little tricky first time when you see it, but you spend some time. Keep staring at it, and you will get it. And of course, we create a memory saver, we create a checkpoint, and now this code is the graph code with the human in loop is running. Now to run this, what we will do here, we'll do Langgraph dev. Of course, you will see all the requirement text, that all the files you need to pip install. So install all that, and then you do this Langgraph dev. When I run this, it's running all this, and this is Langsmith, where you can see this graph is made exactly as we shown before, right? Start, agent, action, human. This is it. This is the graph is running. Now I can interact with this graph. Now this graph is running in my local host here. See, localhost at 2024 port. So I can pass a message here. My message is ask a human for help about what to do with Langgraph. I am some user saying I need a human help. Ask a human. Why I am saying ask a human? Because you've seen in the code, we created a tool, ask the human a question. Because I said ask a human, it will understand. So using this should contain method, it will route to ask human this node, and which will interrupt. So let's see and say submit. Here, as you can see, Langsmith, it shows you all this thread ID, all the messages and everything. So it's a very, very beautiful tool. Maybe in part 3 we'll talk more about it, but today we'll just see. You see here, ask human, it's waiting, it's interrupted. So interrupt is here. Now it's ready for me to resume the graph. So what I'm going to type here is here. Okay. I will show you why I'm copying, pasting, but it's a long message. So this is what JSON you have to pass, data, and this is a human input. It can be anything. The human will say whatever they want to say. And I'm saying here, we the experts are here to help. We recommend you check out Langgraph, blah, 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 and then I'll resume. Now, see, it went back to agent, and agent looked at this, and it gave you the answer to the user. Langgraph is recommended for building agent because that's what I replied in this here. It's much more reliable. Check out Langgraph, build your agent, right? It's much more reliable and all that. So you can see this message here. Now this is with Langsmith, right? And most of the example on YouTube, they show the same thing in notebook, but then you don't know how to move ahead because we are writing Python code. So my graph code is running here at my local. Now let's write a client code in Python to interact with this graph. So let me open my another VS Code instance. Now let's look at the client code. So here we are building a client, calling it get client and passing the URL where my graph is running. My graph is running in the local host at 2024 port number. So then we get a thread out of the client, and this is the input we are passing to the graph. Ask human to help me learn about Langgraph. And we created a structure with role and content, a proper message, and passing it in a client run stream. Here's the message is passed. And you can see the stream mode is update. By that we mean as the update is happening in graph, it will throw back the chunks. And we will look at the chunks and we will just print them out. So here's the message we're going to get from the agent, and then when we'll get on an interrupt, we will print this message, which will be in green color. And then we'll take the user input and then call back the graph. So let me talk till here. So now let me quickly show the graph code, because what we are doing here, we are made a small change. We appended to this message. Please provide your response here in ask human method at the interrupt. Right? When the interrupt will come, we will see something, whatever we have passed, whatever thing has come from agent, from the message, and then we will append to this. Remember, this agent is this state is a list of messages. Now let's run it. Remember, we are passing the first question, ask human to help me learn about the Langgraph. So ask human is a key to the graph to go to the ask human node and throw an interrupt. As you can see, this was the message from the agent. Can you help me learn more about Langgraph? What specific information are you looking for? And what aspect do you need help with? This message is changed and appended by the LLM, because I asked very simple message, ask human to help me learn about Langgraph, and this is what the agent is converted to. Now, this is the message which is out of tool calls, and this is the question is converted by agent. We could have passed this string also from our graph, right? But I just wanted to make it very simple, so whatever message I send, it is just interrupting with that message and then appending, please provide your response here. And you can see, ask human to help me learn about language, please provide your response here. And now we got the interrupt, we can stop it, we can call the human, and the human can come and type their answer or do whatever is needed. So they may say, buy a book, enter. And now this buy a book is gone back to the rest of the graph, which look like this. Ask human, and then agent will respond, and then the graph will end. So here is the answer. If you are looking to learn more about Langgraph, buy a book is a great idea. Okay. Now here you see below this code, once we reply, what we are doing is, we now want to update this thread with a response from the user. We can kick off another run. Because we are treating this as a tool call, we will need to update the state as if it is a response from a tool call. So for that, we want to get the tool ID. Tool ID you get out of the state. And to get the state, you ask the thread, passing the thread ID that give me the tool ID. And this is the response I typed. And then you create the tool message, and you see here content is going as a human response, which is my response here. And then when you update the state of the graph, you give the thread ID, you give the new message, and as node, ask human. So the graph actually act as if the tool responded. It didn't know that a human responded. But actually this is a human, and then we call back again thread update state, and it will update the graph. And then we print the final answer after passing this, because here what happened, when ask human goes, it interrupts human type, then it goes back to LLM. LLM then respond with this response, and then it makes a proper response which tells, if you are looking to learn more about Langgraph, buying a book is a great idea. All that, okay? And then last again, stream is input is none, means stop the graph, so it can go to the end. So that's it. But remember, we had two tools here, right? We created a small search tool which is doing nothing, and here's the ask human tool. So let's see, if I change my query here, ask the user where they are, and then using the search tool, check the weather in that location. So I am just change my query just to show you how the LLM will still understand, and we also get the interrupt and everything. We get the interrupt, and it is the question from the LLM has come, where are you located? This line is saying where are you located in yellow color, and this is the interrupt, ask the human. It did go to my human interrupt, for asking this question. Now, human response can be, I'm in Paris. Is Paris sunny? Enjoy your day. And as you can see, it is sunny in Paris and all that. And it did call this tool, search tool also. So there are multiple tools, multiple ways you can do this. So let me talk about how this search tool also worked with Ask Human. So to understand this, let's quickly look at one last time this image, this one here. So to understand the whole flow, let's quickly look at this. Here's the picture. And as we seen that these are the nodes, agent, action, Ask Human is a node, right? And there's a additional edges called should continue, which will just check which tool should continue is checking the tool call name. If it's Ask Human, because we created a tool called Ask Human here, this dummy object, which is supposedly a tool. So when we say to Ask Human about the weather, it will route it to the LLM will route it to this tool Ask Human, and this tool, it will route it to this tool, which will be used by should continue. This additional edge should continue method to check what tool we are calling. You say, okay, we are calling Ask Human. And that's the cue for the graph to move it to the Ask Human node, where it will throw an interrupt. So that's how even the weather scenario worked. I hope it's all become clear. It's not very simple, especially when you're looking at it first time, but I'm sharing the code with you. So hopefully you spend some time on this and it all become very simple to you. So thank you for your time. Please let your feedback keep coming and let me know what else you would like to see on this channel. Thank you.